Thanks everyone for your time, for joining us today and joining us all to learn a little bit about PowerShell, or for those of you who have been in the trenches detecting and trying to wrap your heads around this, hopefully just you can use this to reinforce some of the knowledge that you already had and gain some new perspective. So I'm personally a little surprised it's taken us this long to do an official threat and technique focused webinar on PowerShell. As most of you probably all know, PowerShell has been abused for quite some time. And we released our threat detection report last week and in years prior. And it should be no surprise that this year, like in previous years, PowerShell has consistently been at the top. This was the #2 technique for our threat detection report, which came out this past Wednesday. And so we figured we'd take this opportunity to just cover the different aspects of what PowerShell is, why and how adversaries are abusing it, and how we as defenders or vendors, whoever, attackers, whatever, can think about detecting and leveraging PowerShell to its fullest.
Awesome. So I guess we're going to go around the horn and do introductions. My name's Jamie. I do adversary emulation at MITRE, as well as lead the team that does technique development for Attack for Enterprise. So I guess in Matt's kind of spectrum of users have been both the attacker in terms of using it for building tools that we use to assess defenses, but also from a CTI defensive perspective in terms of looking at abuse of PowerShell, understanding that, and then codifying it into attacks we can really understand and help propagate what threats are actually doing in the wild. And with that, I will pass it over to Casey.
Casey Parman. I'm the manager and lead for the Carbon Black Applied Research and Offensive R&D team. Kind of the same aspect. You know, we look at the red team side of how to abuse it, but also the applied research side of, you know, what can we as a vendor do to better protect our customers from PowerShell attacks. Pass over to Sarah.
Hey, I'm Sarah Lewis. I'm a senior detection engineer at Red Canary. So I'm always looking for ways to find the evil and clear out the noise. Pass it off to Matt.
And I'm Matt Graber. I'm the Director of Threat Research here at Red Canary. I've been using PowerShell on and off, offensively and defensively, and for legitimate automation purposes for about 10 years. So I've seen the full gamut of offensive tradecraft and leveraging PowerShell for automation to detect its abuse and various other things. Yeah, so at Red Canary, I get to wear both hats. As far as PowerShell is concerned, we use it pretty heavily internally to automate a lot of attacks, whether they're PowerShell based or not. PowerShell is just a wonderful automation technology, and we use that to validate detection hypotheses end to end within our detection pipeline. All right, so what are we going to be talking about today? We're going to lay some groundwork, talk about what is PowerShell. If you are newer to PowerShell, we'll clear up pretty quickly. PowerShell is not just PowerShell.exe. It does comprise more than that. And then we'll start talking about threats and the technique itself. So what is it about PowerShell that is enticing to adversaries, and how are they using it? And then if we want to think about detecting suspicious or malicious PowerShell, what kinds of telemetry is available for us, either as vendors or enterprise defenders, to collect? And then once we've collected that telemetry, how can we effectively reason over that? And we'll start talking about detection and some of the challenges posed therein. And then we'll start wrapping things up, talking about possible mitigations. Now, PowerShell, considering how powerful it really is, let's say an adversary already has full access to run any arbitrary PowerShell commands that they want. At that point, there's probably not a ton that can be done to fully prevent them from abusing PowerShell further. But there are some things that we can do to at least limit the effects of their tradecraft. And then lastly, we'll talk about testing, specifically in the context of testing our collection capabilities. We're going to be talking about AMSI quite a bit. So this is the anti-malware scan interface. This can be tricky to work with sometimes and to validate, like, hey, is this thing on and actually collecting valuable telemetry? We'll get into that a little bit. But first, you want to take it away, Jamie?
Awesome, thank you. So I love the way you framed it earlier in terms of before we even start talking about the offensive and defensive side, it's really important to understand the foundational technology. So PowerShell is it's a tool, it's a technique, it's all of the above. It's an automation framework that Microsoft has been, grooming and maintaining since I believe the early 2000s. The core premise is it's supposed to be almost like a Swiss Army knife for admin. So getting into kind of like exactly that, kind of paradigm, it is a very feature rich. It's intended to be something that you can use to configure systems, monitor them, but also administrate things, make changes. Even if you've kind of had any space or any work in PowerShell, you've noticed over the years, there is a wealth of documentation and reusable resources, whether, most often we'll think about PowerShell in the units of commandlets, which are basically little functions that you can use to, do specific task, or there's scripts and functions and other big kind of more packages and reusable things that are floating around that really give you as an admin, as exactly as Matt was saying earlier, as a legitimate user of PowerShell, gives you a lot of feature-rich capability. But that said, one of the most important things we always do, especially from this threat modeling perspective, is start to look at these technologies and, with that realization where, if an admin is able to, log into systems remotely, run, arbitrary commands, so could an adversary. So it's really important to start taking a look at that technology and really understanding, how this could potentially be abused. So on that note, just a quick overview, and, I think, Matt, you even said it, just a quick overview of what threats are abusing PowerShell. Again, the technology is ubiquitous, and so is the threats, unfortunately. So just a quick reference to the threat detection report that was released last week. There are some notable threats that stood out in terms of abuse of PowerShell in 2022. But one of the big patterns you'll notice is it's across the board. There are PowerShell-based malware. There are a lot of adversaries that do a lot of interactive, command execution through PowerShell. But you'll also notice it's just included in almost every other type of threat, whether it's, something, malware in a different language. We'll very often use PowerShell to invoke commands, or as part of its, some other aspect of it, thinking like persistence. And even those, Word docs, a good example, like a Word doc using like macro VBA language, that might even invoke PowerShell as part of its like, staging and power kind of loading implants into victims. So it's one of those things. From the attack perspective, we track PowerShell in one sub-technique under the execution tactics, T1059. The first sub-technique, very good ordinal there, because it is a very big part of that command and scripting interpreter technique. But that said, I don't have exact hard numbers on this, but it's one of those kind of techniques that, anytime we see a new threat report or we're looking at a new piece of malware, it's almost a given that PowerShell is included. It's not, and again, it's not just that, very classic paradigm of loading PowerShell.exe and running commands. It's really all over the place. And that's something we'll get into a little bit, especially from the detection perspective that, again, like Matt said, it's not just thinking about PowerShell.exe. So a little bit of a kind of a quick timeline on PowerShell. One of the quick, especially PowerShell abuse, one of the very common paradigms we'll notice with offensive tradecraft is, there will be some new technology or some new, way of doing something slick. And in this case, executing commands, and adversaries will overfit to it. Everyone adopts it. It's in all the red team tools. It's all in all the briefings, all the malwares, kind of jumping over to PowerShell. And we saw that. But very often what happens is, as the adversaries and as the offensive engineering kind of, goes a certain direction, so do the defenses, and those types of tradecraft get burned. and burned in the sense of it doesn't really work as effective anymore. The interesting thing about PowerShell is it survived that paradigm. You know, it's such a powerful and feature-rich and, you know, organic part of so many different systems that, you know, thinking about even probably mid 2010s, there was so much PowerShell tradecraft. It was the new hotness. And even today, like, you know, earlier today, I was looking at threat reports and we're still seeing PowerShell all over the place. So it's going to be one of those things, especially as a defender, it's not going away. So it's something that you really have to start to, whether or not you're already kind of in the weeds in terms of detecting and mitigating PowerShell, it's not going anywhere. So quick kind of timeline. So like I said before, a lot of, at least in my experience, a lot of the early PowerShell tradecraft came out of like red team tools, thinking things like, you know, POSH-C2, Empire. If you go to attack, funny enough, if you scroll down through like the software pages, there's a bunch especially in the Ps. There was a huge wave of malware that, you know, named by power this, power that, a bunch of PowerShell based malware. Interesting enough, though, is that's one of the reasons that PowerShell survived was the level of depth and the breadth that it's capable of. So coming from those just strictly PowerShell based malware, we also saw a lot of kind of advancement of the tradecraft of using PowerShell. So, you know, examples of, you know, executing PowerShell without PowerShell.exe, but also looking at the capabilities of PowerShell in terms of actually getting to that .NET underbelly and, you know, being able to execute arbitrary APIs or load other code. But also one of the other interesting projects was just how flexible PowerShell is in terms of obfuscation. So a lot of, you know, PowerShell really started to build out as this foundation for so many different techniques and tactics. And even more on the technology side, looking at recent changes from Microsoft, PowerShell is becoming more ubiquitous in terms of it started as a Windows-centric technology and has since over time been adopted in, you know, Active Directory and cross-platform, even, you know, thinking about Linux, but also Mac OS. And then, you know, as more and more things push to the cloud, that same kind of paradigm of, you know, that automation sysadmin tool is also started connecting to, you know, things like Azure and, you know, other scripting capabilities and those different platforms. And like I said, even today, I think this was from a couple of weeks ago, we're seeing adversaries invest in more, you know, even if it's just tiny little changes, but in this case, using like signed Microsoft scripts to invoke PowerShell. So this is something that, again, it's that wheel that's going to keep churning. So the more that we can kind of understand both the scope of the problem, but also a lot of these quick and easy wins that we as defenders can take advantage of, you're going to make a lot of big wins for your organization. So with that, I'm going to turn it back over to Matt to talk about some of the PowerShell-based telemetry.
Thanks, Jamie. One comment I wanted to make on the previous slide, you highlighted as like sync app v publishing server. When I see things like that, like when you actually dig into the implementation of silly tricks like that, I just want to point out, like, that speaks to how far we as defenders have progressed, that like when we're forcing adversary tradecraft to do like dumb tricks like this, you know, it's testament that yes, confirmation that this is absolutely a cat and mouse game, but so long as we keep engaging in that cat and mouse game, I'll take any progress that I can get. So that's definitely a win to me. So speaking of progressing detection, if we want to get good at detecting anything, we need to know exactly what we need to collect. So what telemetry is available to us for PowerShell, both as a vendor and as an enterprise defender? So first, let's talk about Scriptblock logging. So this is, in my opinion, by far the most valuable logging source that an enterprise defender or many security vendors, for that matter, can tap into to get a very high fidelity timeline of what exactly occurred in a malicious PowerShell timeline, with some caveats, of course, that I'll cover. So Scriptblock logging was introduced in PowerShell version 3. So we're not going to enumerate all the bypasses here, but one such bypass would be if, say, PowerShell version 2 was installed on the victim system, an adversary could certainly just load that. There's telemetry to detect when that's loaded as well. So, and hence the cat and mouse game will continue ad infinitum, but that's okay. Assuming we're not dealing with bypasses, all Scriptblock execution is logged as a 4104 event in the PowerShell event log. Now, when I say Scriptblock logging, a Scriptblock is any individual units of PowerShell execution. So there are different aspects of the language that would constitute a Scriptblock that would be logged. For example, if you were to execute a script or module off of disk, that would get its own dedicated 4104 event. But there are other means as well. So many of us have heard of the advent of purely in-memory PowerShell tradecraft. That's going to be captured as well. One of the most heavily abused inbox PowerShell commandlets is invoke expression. So that just takes a literal string and interprets it as PowerShell code and then executes it. So that would be logged as well. We also see a ton of PowerShell download cradles where the minimal PowerShell code will reach out to a C2 server, again, download a malicious PowerShell blob, usually as a text string, or it may be encrypted and encoded, and then subsequently decrypted and decoded, and then executed with something like invoke expression. All of that is going to be logged, so you don't have to rely upon PowerShell, malicious PowerShell code being just on disk to get the full context of what executed, whether it was captured, downloaded and executed via a C2 server, or let's just say it was heavily obfuscated code that had varying layers of deobfuscation. You would, in theory, with these 4104 events, be able to capture in a rich timeline everything that occurred as it was subsequently deobfuscated, downloaded, so on and so forth. So there's two different types of Scriptblock logging. The first is automatic logging. This is turned on by default. It actually can't technically be turned off. Well, adversaries can turn it off with a little bit of PowerShell code, and we'll cover that as well. But you get really great inbox logging without having to explicitly enable deep Scriptblock logging, which captures everything. And we'll get into the distinction between those two in the next slides. So this really does empower enterprise defenders and vendors as well to gain rich insight into PowerShell tradecraft, whether it's actual malicious material, your canonical drunk admin doing silly drunk admin things, to legitimate benign stuff that you'd want to suppress in your detection timeline. One caveat to mention, the PowerShell log, along with many other event logs, are globally readable. Some adversaries are aware of this fact. So let's say that you're a scapegoat drunk admin doing silly admin things, happen to have plain text credentials in his or her script. An adversary who compromised that system would be able to see that. So even if the admin was running in an elevated admin, system level context, even as an unprivileged user, the adversary would still be able to see every PowerShell event that executed regardless of the user and process integrity level context. And I've mentioned this before, AMSI and PowerShell Scriptblock logging are subject to trivial bypass, but even as defenders, we still have opportunities to detect all these things. Pretty much every bypass in existence has some form of signal that we as defenders can rely on to detect. So automatic Scriptblock logging. Again, this is on by default, assuming you're running PowerShell version 3 and above. PowerShell itself, and Jamie mentioned PowerShell is not just PowerShell.exe. This is all implemented in system.management.automation.dll. That is the core of PowerShell itself. And within that DLL is this list of dirty words. And people like Lee Holmes and the PowerShell team at Microsoft at the time, when they were going through and doing an audit of all of that day's existing malware, what they assessed were these keywords, these methods, these properties, these fields, so on and so forth. These were used very heavily by adversaries. And not only that, they're usually exclusively used by adversaries. There are some exceptions. For example, add type. That commandlet is used in legitimate contexts all the time. But some of these are really unique to a lot of the offensive PowerShell malware out there. And what's really cool is when these are logged as a 4104 event, it's logged at the warning level. So if you have enabled deep Scriptblock logging, the way you would distinguish a dirty word being triggered versus logging of everything else is the verbose versus warning logging level. So if you're investigating an incident and you need to do some like rapid triage and just pull out what you suspect might be the more likely stuff to be suspicious, pull out just those warning events first and then dig in further to the more verbose logs. So as I mentioned, Scriptblock logging, it tells a story. So I came up with a silly example here. So just imagine this being like one of those typical PowerShell download cradles where it reaches out to a C2 server, downloads some PowerShell, and then executes it using invoke expression. So I mentioned that invoke expression being logged would log its own Scriptblock. So hence, this is why you see two Scriptblock events here. The first being invoke expression being called, and you see the context of the payload that was supplied. But if there was actual like subsequent PowerShell content that followed, say that also executed invoke expression, you would see this gradually unwrap in the logs and get that great context, even if it was executed entirely in memory. All right, so Casey is going to talk about the anti-malware scan interface now.
Yeah, so Microsoft's next answer to the cat and mouse game was, AMSI, the anti-malware scan interface. It was introduced in Windows 10 Server 16. We call it the gift that keeps on giving. It was an API that security solutions can use to inspect content in real time. This content can be anything from interactive commands, scripts, macros, or any other form of executable code. As we talked about a lot, PowerShell isn't just PowerShell.exe. Even AMSI uses the system management automation DLL to interact with AMSI. And so that means if, you're doing stuff as PowerShell, but you're not PowerShell, it will still be recorded via AMSI. This allows for real-time protections against malicious activities. So as we can see here, the content is inspected by AMSI and it's blocked in real time. This is a form of an AMSI bypass. And yeah. So AMSI providers, they're a software component that actually interacts with the AMSI. So supported versions of Windows automatically have a default AMSI provider built into Defender. Its contents are scannable via the Microsoft anti-malware scan interface. The event provider is associated with the mpova.dll. So that is the actual DLL that is calling the AMSI API for Defender to use. It's common for security vendors to create their own AMSI providers, but not all vendors will actually use event providers for logging. How the content is logged will be at the discretion of the provider or whatever vendor is doing it. And in many cases, they could be logged to the system or even just sent up to the cloud. All of the event providers on the system are in the AMSI providers registry key within HKey local machines, software Microsoft providers, and the COM GUID for each DLL is located under CLS ID, shown here. So here, I'm not sure if we can see it, but we can have multiple providers on the system at one time. We don't just have to have one. In addition, AMSI Provider actually supports Authenticode sign check with Windows 10 1903. This can be enabled or disabled via the feature bits registry key. It is disabled by default, which means that any AMSI provider can ingest content. The AMSI Authenticode linked here can be used to show the current status of the feature. Can also be used to check if it's enabled or disabled, and enable it or disable it. So as we can see here, when it is disabled, we're able to successfully register an AMSI provider, and the PowerShell executable loads the provider's DLL into the process. When we have Authenticode check enabled, we can still register the provider as we normally would, but when we load PowerShell, it is no longer using the DLL for AMSI inspection. So with all of these things, we still have. Oh, go ahead.
I was going to say, one thing we were talking about before was like, what's your opinion on like the accessibility of like the average defender to like AMSI? Like, I think we were discussing before, it's almost like something that it's good to know how your tools work under the hood, but it's probably a little bit of a rough interface for like, if you were just like sitting down and trying to generate your own logs, like AMSI might be a little bit in the weeds, or what would be kind of your recommendations there?
I think AMSI is good for when you want to test or you want to understand, or if you're doing some kind of dynamic analysis. I don't think it's good for installing your own AMSI provider on a fleet of 1,000 boxes within an enterprise. While it could like get great data for you, it could also cause issues. There's overhead with AMSI with anything else, depending on how you're logging or how you're inspecting the traffic. We'll get into it a little bit later, the AMSI provider that I'm using in these tests, but one code issue and PowerShell no longer works successfully because it stopped the pipeline from even communicating, even though it's not in a blocking state. So it can be very tricky, and you need to make sure that if you are using an AMSI provider, it's typically one from a trusted source, like a vendor who does a lot of code verification checks.
Yeah. Thank you. I think we tried to enable it on like one host, and it got brutal really quick. So it's, like you said, it's good to.
Oh yeah, I bet. Well, especially with, so AMSI is far outside of PowerShell too, so it hosts a lot of interesting things like Exchange. And so if you put it on an Exchange server without any filtering, you're going to get a lot of different useless logs. There might be something that is useful, but without tuning it and knowing what you're looking for, it easily take down the system just from the overhead from it. All right. So as Matt mentioned, with Scriptblock logging, AMSI can also be bypassed. Like we said, it's a cat and mouse game. We get a solution to stop them and figure out ways to do it. AMSI isn't a silver bullet. So AMSI.fail is a popular website to generate known methods for AMSI bypasses. However, there's a large number of additional ones, as you can see to the right. There's downgrading, registry changes, hooking, patching, DLL injection. AMSI is also fail open. It's probably the most important key here. If there's any type of issue within AMSI itself, it will return a results not detected results, just to make sure that it doesn't stop anything. That's different than what I mentioned earlier with like a code violation of, actually stopping the whole process. But so here we can see a good example. This provider blocks the word cat dog. So we have a block, and then when we go and bypass AMSI, we can then see that the block no longer occurs. It's because it's no longer hooking. This is a patching method that is being used to bypass it. But in that same sense, as Matt mentioned earlier, with all of this logged, as you can see, the actual bypass is logged below. We can create detections to actually block the bypass from occurring in the first place. So AMSI also has other additional challenges. As Matt mentioned, depending on how it's logged, different credentials are a key thing that we would see a lot in AMSI content. This is because it's not just interactive commands, but it's any scripts, it's any macros, it's thing that you can see here. We have a local account and even Office 365. As Jamie mentioned at the very beginning, there's a lot of PowerShell automation for Office 365 now. And so if you guys are putting your credentials for your admin access for Office 365 inside of an AMSI script, those are stored somewhere. And depending on who your vendor is, it could be in your event subscription, it could be locally logged, it could be in the cloud, it could be a number of places. So it's very important to understand what is being collected and where it's being stored. But this also gives, AMSI gives researchers, defenders, and even red teamers different options for receiving and analyzing AMSI data. So we'll talk about it a little bit more, but if you do install your own AMSI provider, you can gain visibility into the content that's being executed. But like I said, I wouldn't recommend that in like a production environment type of thing. And I'll pass it over to Sarah.
So the threat detection report has a great overview on PowerShell, and there's just a ton of information out there in general on specific TTPs, threat actors, attacks, etc. And I don't have time to get into the weeds on creating specific detection logic. I mean, the section could easily take up the entire hour. I feel like all of our sections could probably take up the entire hour. So this is going to be a high-level overview on detecting PowerShell abuse. So the first thing that's most important, it's kind of been touched on, is understanding normal. And that's understanding what's normal for PowerShell, like what child process does it usually spawn, what are some normal parent processes it could have depending on how it's executed, and then also understanding how admins use it in your environment, because admin usage varies from place to place. In one environment, it could be super sketchy for an admin to add a new user in a certain way using PowerShell, but in another environment, that usage could be completely normal. So having the understanding of how it's used in your environment, seeing what's normal there, once you get that understanding, then it can help you see the stuff that's unusual. So having particular parents or children processes writing files either to certain directories with weird file names or certain file extensions, making network connections, like all that stuff starts to become more visible once you have the understanding of what's normal. And then there's also like the idiosyncrasies that happen often in malicious usage, where when someone's been doing this a lot, they'll say like, oh, I can just look at something and tell you if it's malicious. That's because of like the unusual formatting that tends to pop up a lot in malicious PowerShell execution. And then the big key is you want to look for combinations of terms and behaviors, because if you just focus on one little piece, then you're probably going to have a bad time. You're going to end up getting lots of false positives. So for the unusual formatting, this is an example of something where like you can just look at it and see that it's malicious. If I saw this command line, I would know, okay, I'm going to have to dig into this and write it up. Even if it was something that like didn't fully execute, there was no follow-on activity, just the command line itself, because of how it's formatted, the obfuscation, that's going to tell me like, okay, this is weird. So you can see here that it is splitting up a download of a file. So here's one piece, here's another piece, the rest of the web client first part of download. here's the rest of download string. This is the URL, and it's like trying to pull down a JPEG file, which is super weird to download. So all the way that it's split up, the random variable names here, using the string and replace, like all these little things together, and having also the mixed casing. I don't know why, but for some reason that pops up a lot. Random like casing that you wouldn't normally see. So that on its own obviously isn't an indicator of maliciousness, but just all these little things together then help you see like, oh, this is something I need to take a closer look at. Also, single letter variable names get used a lot. That can happen too in normal activity, especially if someone's just like testing something out. So again, that on its own isn't necessarily malicious, but just looking at all these things from a higher level, like together, then can help you start finding the malicious stuff. And so here is a good example of like combination of terms and behaviors. So this is a partial TA577 command, and you can see that it's calling invoke web request, starting run DLL 32 to execute this file with a DLL with a weird name, and this WW50 is a super weird function. So even within like the child processes that get spawned from malicious activity, there's still more stuff that you can get into on like what's weird for run DLL 32 to do. But this alone like is a good precursor. So if you're just looking for invoke web request, you're gonna have a bad time. Or you're just looking for child process run DLL 32, you're gonna have a bad time. But combining those things together can help you weed out some of the benign behavior or admin stuff. And again, too, like, this is what we used basically to detect this behavior, but there's other things in here that you could combine as well. So it's really just kind of figuring out, looking at what's malicious, or seeing a write-up of something, and maybe if you can't detect it yet, just pulling out the little pieces where you can make a detection logic that isn't so broad that you're going to pick up like everything your admins are doing, but it's not so specific to a TTP that once that TTP changes, you're not going to be able to detect that activity anymore.
It's also a good feedback loop for your admin, like, hey, like that syntax is really sketchy. Could you stop doing that if possible?
Yeah, 100%. If you're like seeing this stuff, if your admins start doing something and it's like alerting in your environment, then it's definitely a good conversation to have about like certain practices that would be better than others, just to then help further lessen that kind of noise in your environment. And now, detection challenges, there's a ton. I'm going to talk to like the few, like there's 3 that I think are like the biggest things. And so one is using single strings behaviors to find evil, like I've mentioned. This command line is one example. So this was some detection logic that was basically just looking for bitwise XOR usage by PowerShell, so just TAC BXOR. And while yes, that does get used maliciously, like every commandlet and function and stuff that can be used by PowerShell isn't inherently malicious. It had a benign purpose to begin with. So just focusing on that is going to bring up stuff that you don't want to see. So like this TSSV2, like just looking at that, I would see that command line and be like, oh, this isn't malicious, because I've seen it before. And what this is the Windows troubleshooting script tool set, which is just something to help like figure out what's going on. There's a lot of different things that can be run, And so this was just happened to be a script related to that tool set that had the bitwise XOR in there, but that activity wasn't malicious. So when you use the single strings of behaviors, then you have to waste a lot of your time just weeding out all the false positives. And that's never a fun time for anyone. And then
I think it also takes it back to knowing what's normal in your environment.
Yeah,
Because if you've
definitely.
never seen something before and all of a sudden it starts showing up, you know, something changed.
Mm-hmm. Yeah, definitely. And then false positives from substring matches are also something to overcome. It can happen a lot. Like you can have something that you think is great detection logic, like this is going to find all the evil, can be a combination of things. So like IEX and download string together, and then, or IEX and like a referencing to certain like registry locations or registry hives in the script or the command line. And then great, cool, you put it in production, and then suddenly you're getting bombarded with false positives. And why? Because IEX is also part of MSI exec. So one of the hits from the detection logic isn't actually a positive because it's a substring match. But if you put a space on either side of IEX, you could potentially miss things, because I do one example of that is something we already saw, and that's here. Each instance of IEX is surrounded by some like parentheses, semicolons, single quote. So if you have spaces, then you're going to miss that. But if you can use something like regex, you can say that you want to ignore anything that has a word character on either side, some similar type of regex, and then that can help you weed out some of those false positive hits and make it a little bit easier to find the evil or suspicious stuff. And then,
So one thing really quick, that also comes back to knowing what data is available, because maybe in that situation for IEX, at least, on that specific event isn't where you'd want to detect it, but later when it actually does the IEX execution, you might see some data differently to correlate it back to that original one and have a better detection. So knowing the different execution steps for something also could really benefit writing detections that are correlated together.
oh yeah, definitely. That's a really good point. All right, so the final detection challenge I want to highlight is when the good does bad, because when you're learning, you're like, okay, cool, I have a pretty good understanding of normal, and I have a pretty good understanding of what's evil. And so now I'm going to find all the things, and then you're going to run into some like junk admin or developer or something that's going to be like, cool, this is probably really bad. And then you start to dig into it, and it's actually benign. So first is Excel's loading system management automation DLL, and like was mentioned before, this DLL is PowerShell. So weird, an Office product loading this DLL. So why is this happening? You start to dig into it, and then the file path that it's in looks like it's related to printing. And so then all the surrounding DLLs and behavior that's within the Excel process, turns out it was loaded because it was something that was related to HP smart printing. Why? I don't know, but it was not benign, or it was benign. It was not evil. So that's cool. You're digging in. this process loading this DLL, it's going to be bad, and then it's actually not. So finding those things too, and then having to weed that out as well, being aware of just like the bad practices of other people. And then this one, fun AMSI bypass. So here, this is something that I would look at it and say, this is completely malicious. Like, not a doubt in my mind. Look at all that obfuscation, right? But then there's a comment, and it's Matt Graber's reflection method. And while, yes, I mean, someone could take this and use it maliciously. Typically in malicious execution, you don't see a comment like this. They can be there sometimes, but it's not usually. I wouldn't expect to be working and then be like, oh, Matt Graber's reflection method, cool. So this triggered stuff based on the obfuscation, and then looking into it more, oh, the script load, the script file itself was from an EDR vendor, and they are using this AMSI bypass just in their script. So looks super malicious, super weird thing to do, but it was actually benign activity, and that took a lot of time to figure out. But once we figured it out, then you're like, okay, this is weird, but if you see this like script file name or whatever, there's certain keys that you can hone in on with this weirdness that then you can exclude that and help lessen the noise a little bit more. All right, now pass it off for talk on mitigation.
Yeah, Zara, that was definitely one of those cases where context is key. And if you're able to, say, like within a customer environment, like suppress based off things other than just the PowerShell code, there was a particular process that consistently launched that bypass. So that's something, just going back to your point of like context and behavior is key if you're going to detect these sorts of things. So yeah, that was definitely one of, it was funny, but it was also painful at the time, considering it was a vendor and the scale with which the initial compromise, quote unquote, occurred.
Yeah, we just had to laugh so we wouldn't cry.
Oh, but yeah, lessons learned, and that's no longer an issue with that particular vendor. But I mean, we all do silly things, and no one is immune from being silly and not knowing the best thing to do. So with that, let's talk a little bit about mitigation. So the one built-in feature that Microsoft gives us for mitigating the impact that suspicious and malicious PowerShell would have is called constrained language mode. So this is enabled automatically in concert with either an app locker or a Windows Defender application control, or WDAC, policy being enforced. So yes, there is a higher bar in play to enable this. But if you are one of those environments, and I personally run this on my personal machines, once you've developed a policy and like your software baseline is stable enough to allow an application control policy to be placed into enforcement mode, you'll actually rarely notice that constrained language mode and the policy is even on in the first place. Another cool thing is that constrained language mode bypasses, like if you have a core like fundamental bypass to it, Microsoft considers this to be a serviceable bounty or security feature. So you could report that to MSRC and potentially get yourself a bounty, which is pretty cool. So how is this actually implemented? So it takes some of the core language features and prevents you out of the box from executing those. One of those would be like add type, which I mentioned before. Attackers use this pretty frequently, but there's also legitimate use cases for it as well. This is the commandlet that allows you to supply arbitrary C# code, which PowerShell would compile and load and execute on the fly. So right out of the box, you can't do that. But fortunately, if you do have legitimate code that does require something like add type or any of the other language features, which I'll cover in the next slide, requires any of those, then you can just allow that particular script either by signer, by hash, by directory, so on and so forth. So it's not like you can't do the things that you legitimately need to do with constrained language mode being enforced. So what might an adversary or a user or admin see, not expecting this feature to actually block some legitimate or malicious activity? So you could see add type in the first example is being called, and right away, like, it just errors out. It's not going to execute that. Same would go for the system.reflection assembly load method. This is definitely a favorite of attackers. This is what allows an adversary to use 1 or 2 lines of PowerShell code to download a malicious .NET assembly, DLL, or exe, load it in memory, and then execute it. So in constrained language mode, because in this case, that load method is a static .NET method, you're not allowed to call any static .NET methods with a few exceptions here and there. So that is blocked right out of the box. Now, let's say I was a crafty attacker and thought that I could outsmart PowerShell, and instead of running add type dynamically at the command line, why don't I just drop it to a PS1 file and then try to execute add type as running as a script? Well, PowerShell is smart enough to figure that out, and it's going to block that as well. So this is just a small subset of the language features that are restricted when constrained language mode is enforced. Another benefit that you get when you enable App Locker or Windows Defender Application Control is that any scripts or modules that are loaded will be logged in the App Locker, MSI, and script event log. And yes, I said that correctly regarding WDAC, so Windows Defender Application Control. Those logs also go, the script block logs, or the blocked execution logs of scripts, goes to the App Locker log. So not to be confused with the PowerShell event log, and not to be confused with the code integrity event log that blocks like portable executables like EXEs and DLLs and device drivers. So these are separate logs here. But a great potential supplementary data source, if you do have that environment where you are enforcing or even auditing App Locker or Defender Application Control. If you're in audit mode, you get these logs as well, which is really nice. All right, so I mentioned we would briefly touch on testing. And in the interest of time, we were just going to focus on testing AMSI. Casey already alluded to some of the challenges with incorporating AMSI telemetry for practical purposes. Like if you're anyone like but a commercial vendor, I personally find the AMSI logs to be extremely valuable though, for saying like, hey, is this EDR solution actually on? Like, does it log AMSI events? So what I will do is I will start a local AMSI trace using the command line syntax that you can see in the slide. And then once you get a PDF of these slides, you'll be able to click on this, but you can just search for the send AMSI content function. This was a PowerShell function that I wrote that allowed me to send arbitrary quote code, but really just any arbitrary string I wanted to the AMSI provider, where I could also tab through the supported AMSI clients to emulate these things executing suspicious code. So for example, this is me emulating JScript running. I could tab through and do VB script. Exchange.net, volume shadow copies, PowerShell, you name it. There's a lot of support for AMSI, and this allows you to just very easily test that. And then there's also get AMSI event, another function that I wrote to ease parsing out those logs and make them just a little more human readable. Casey?
Yeah, so one thing really quick, it's important to know where your vendor or your AMSI provider stores your logs. So when you use Matt's powerful script to test AMSI, you can go to that solution and make sure you're seeing what you expect to see. It's a great tool. So I created, well, actually, so first, so installing a local AMSI provider is great for testing. As we mentioned earlier, I wouldn't put it in a complete production environment, but it's good for assisting in knowing what data there is, or if you're doing any kind of dynamic analysis for any type of process that interacts with AMSI. So this was a provider that I developed in order to test AMSI. This provider actually utilizes Yara in order to detect and respond to specific AMSI content. This provider can be registered in a blocking or non-blocking mode. It'll log it to trace logs and then also locally to the JSON as JSON events in the AMSI.log. The log will indicate if a match was found on the Yara rules and if action was taken. So as we can see here in the non-blocking mode, the Yara rule matches on the string cat dog and the log indicates that the match was detected on it and it allowed it to execute. If we load it in a blocking mode with the command line blocking inside of the DLL install argument, it will block the content from executing and it'll also log it as blocked. So this is also a good indication for knowing where and what capabilities your AMSI provider has. In this case, I'm logging it to multiple things, which means if I'm passing sensitive information into it, and it's a compromised box, then the adversary also could utilize these logging sources to find sensitive information. And then finally, if we utilize Matt's send AMSI content script, we have the ability to actually digest how AMSI as a whole works. Here we can see the AMSI content is it's capturing the execution from PowerShell in blue, but then we can also see in red it's also capturing the execution through JScript. So this allows us to see how one thing calling another, actually, if you digest it even more, the PowerShell is calling .NET, which then calls JScript. So you can see like the whole chain of execution, and it's all actually captured inside of the AMSI log. So even though you don't even see it in PowerShell, there's a middleman here.
So I think with that, we will leave it at that. And just want to thank everyone again for joining us. Hope you learned at least a few things. PowerShell tradecraft, as many of you probably already know, there's really not at this stage in attacker tradecraft like anything terribly novel these days. It's really just like as defenders, like needing to keep up with that cat and mouse game. We haven't seen a ton of like novel adversary innovation. It's really just adversaries recycling a lot of the tried and true tradecraft that has served them well and continues to serve them well to this day. PowerShell truly is powerful. I like to say pretty frequently that like there's nothing that an adversary can't do in PowerShell, with the exception of like implementing a kernel like device driver. So it really is powerful, and adversaries still use it day in and day out, even in really stupid ways, but also pretty sophisticated ways. But fortunately, as defenders, we've seen a lot of this stuff, and so the initiative and the onus really is on us as defenders to truly tackle this persistent challenge. So thank you again. And Jamie, Sarah, and Casey, really appreciate your time and expertise here.